Oke, oke, kayaknya udah mulai live. Oke ya, halo semuanya, selamat malam. Terima kasih buat teman-teman yang udah menyempatkan hadir pada malam hari ini. Oke, sebelumnya mungkin perkenalan dulu. Oke, mungkin sebagai saya perkenalan terlebih dahulu. Nama saya Bahril Kirom. Saya akan jadi moderator pada uh, Meetup pada malam hari ini di bulan Juli. Jadi Meetup kali ini kita partner sama VIDA. Uh, Oke, iya, langsung saja kita mulai. Oke, jadi mungkin pertama saya akan menjelaskan untuk agenda pada sore ya atau pada malam hari ini. Pertama bakal ada Kubernetes Community Update, terus untuk talk pertama bakal ada dari Himalaya Gupta dan Pavan Kumar as a software architect di VIDA. Terus untuk talk kedua bakal ada dari Zufar Dhiyaulhaq as Engineering Manager dari GoTo Financial dan nanti bakal ada Q&A plus ada announcement. Oke, mungkin pertama dari Kubernetes Community Update. Pertama, kita last meet up itu ada di bulan Maret kemarin di Gojek. Terus buat terakhir juga kita ada di Mei 2023 itu ada di Microsoft dan itu termasuk meetup kita yang paling ramai ya. Sekitar partisipan itu ada 100 lebih mungkin. Termasuk paling ramai. Itu kita partnership dengan Nginx dan F5 serta Microsoft. Terus untuk CNCF update, kita ada CNCF update ambassador application di bulan Juli. Ini masih ada buat teman-teman yang masih pengen nyoba, itu bisa. Terus juga ada Elevate Mentorship, itu di bulan Agustus 2023. Terus ada CFP juga, ada beberapa CFP, itu teman-teman bisa cek aja di event Linux Foundation. Itu bisa coba cek-cek aja dari bulan Mei sampai Oktober ya, masih ada nanti sampai Oktober. Terus juga kita ada CFP juga, itu yang collocated event, jadi ada beberapa topik. Itu pertama ada app developer, ArgoCon, BackstageCon, Cilium, Cloud Native Telco Day, Cloud Native Wasm, terus Data on Kubernetes Day, DBAS, Envoy, dan ini CFP masih sampai 6 Agustus. Ini ada linknya juga. Nanti slide ini bakal kita bagiin juga di GitHub kita. Jadi teman-teman bisa stay tune di sana aja. Oke, mungkin bisa langsung aja untuk pemateri pertama kita dari Himalaya Gupta. Oke, sure. Oke, I will try to bring up you first. Oke, hi.
Hi.
Hello everyone. Okay. Can you share your screen, Himalaya?
Yeah.
Okay, I will try to bring up your screen. Okay. Can you share screen again? I think your screen is not visible in here.
My screen is visible.
Not yet.
Let me try again.
Okay, sure. Okay, yeah. For now it's visible. Okay. I think your screen is already visible. And yeah, I think time is yours.
Yeah.
Good luck.
Hello. Thank you. Hello everyone. Myself Himalaya, and I have my colleague Pavan. We both work at VIDA in the back end, and Pavan works in the SRE team. So we are here to talk about what are the pathways that we took in order to transition from a VM-based environment to container environment. So primarily at VIDA, we started with the VM environment of deploying our services, and then later we transitioned into container platform. And we would like to share our journey, how we transitioned uh, from the VM to containers, right? So to begin about some introduction about VIDA, what VIDA does. So VIDA is into a digital identity platform wherein we provide various core functions such as identity verification, certificate lifecycle, digital signatures, credentials, and also biometric authentication, right? So mostly our services deal around digital identity, and its various use cases are across multiple domains, ranging from banking, telecom, fintech, lending, buy now, pay later, etc. So primarily, this is what VIDA does, and let's get into our topic for the today, right? So, uh, what is the reason that we started looking into transition to containers, right? So, traditionally,
Sorry, Himalaya.
yeah,
Okay, sorry. Can you try to slideshow? So yeah, the slide is will getting bigger,
okay,
more better. Okay, sure. Thank you. Great.
okay, yep,
Nice.
thank you.
Ah, ah,
So,
but oh, sorry. But if you are doing the slideshow, the screen is
oh
is missing.
yeah,
Yeah.
okay, maybe I will
Sorry, sorry.
do this. This is better.
Oh,
Let
wait.
me present again.
Can you
Yeah,
try? Uh, can you try reshare your screen again? Okay, sorry. Okay, yeah, yeah, it's better. Sure, thank you.
okay,
Great.
sure.
Okay,
Okay, so
go on.
let's start with the simple question of as to why we should be transition to containers, right? Like what benefits we get, what are the advantages, and what is the prerequisite and pathways to move to containers, right? So let's look at our history, right? So uh, traditionally we deploy on bare metal, wherein we have a physical server and multiple applications running on it. Then we transition into VM based environment wherein we have an hypervisor and it runs multiple virtual machines, and each virtual machine is kind of hosting an entire application into itself, right? Now what are the problems there, right? So traditionally uh, we have been doing VM based, but and on these VMs we will be running our services, and in today's modern technology we prefer most of the things into microservices, right? So historically what we observed was most of the microservices, they are not utilizing the greater number of resources to its complete usage, right? So the CPU utilization never goes beyond 1 or 2% of the CPU. The memory usage is always like 30 to 40% of the memory. So you're bringing up a VM which is having say 8 GB of RAM and say 4 for CPU. These resources are lying idle in the terms of VM environment, and we are not able to utilize our resources to its complete extent, right? Now what happens when we move to containers? We get higher density, right? You can start packaging or start hosting more number of applications within the same set of resources, so your resource utilization is much more compact, right? You have better elasticity. What we say is that uh, you can increase and decrease, or you can scale up, scale down, however you would like your applications to behave, and all of this can happen runtime. So it's like a elasticity, right? It's like a rubber band. You can stretch it how much you want, and then you can again bring it back uh, to a lower based on your traffic and other usage parameters, right? And then increased portability, right? So we have always been that, hey, this works on my desktop but it doesn't work in production. So portability, a very simple example would be if the image is up and running on your on your laptop, then the same image will be up and running on your production environment also, right? So that increased portability you bring in, right? And then scalability, but little bit advanced, wherein you can define various parameters on how you can scale the application and what will be the parameters that will decide that, okay, based on this parameter we'll scale the application, right? Say you can say if the CPU usage is going beyond a certain point, scale the applications. If the memory usage is going beyond a certain point, scale the application. If the total number of requests are coming in are going beyond a certain number, then you can scale the application, right? So these are very simple examples, and you can have much more complex scenarios where you can define that if certain condition is met, then we can scale up the application, right? So before starting containerizing, right, now we are already running our services into legacy mode, that is on the VM based, right? So and then we have some old systems, and then we have some new systems, right? So I will let Pawan take over, where he will try to discuss about before even trying to containerize, what are the prerequisite strategies we need to think about.
Yeah, thanks, Himalaya. So now that you have identified the service which you want to move to Kubernetes, so now what are the steps? How do you go about containerizing them? First, you have to, of course, analyze the application, analyze and make your application ready for the Kubernetes environment. First thing would be understand the application dependencies and its communication on the existing VM where you're running. And you take a decision whether to containerize the application as a whole, or do you want to split that application into multiple different containers. And also, we cannot just move the existing application to code, the application code base directly to the Kubernetes environment. You have to adhere to certain best practices of the container environment that it provides. For example, the containers are meant to be ephemeral, meaning they are disposed and replaceable at any point in time. So you have to cope up with for that particular event, wherein you have to implement certain code changes on your application to gracefully shut down your application, uh, which can handle all the in-flight requests before the application container goes down. And also you need to implement certain health checks like liveness and readiness, where the Kubernetes can figure out whether your application is able to receive and handle the traffic, and make your configurations as configured from the environment variable. Keep all your credentials and secrets in a secret store, example like that, right? Next, now that you analyze your application and made your application ready for Kubernetes environment deployment, you go about choosing the container strategy, like determine the containerization approach, whether you want to use Docker, whether you want to use Containerd or any other runtime specifically for for your application. And you also define certain boundaries for your application, whether to containerize your entire application as a whole, or do you want to split them into multiple containers. So once that you're decided on that, now how are you going to manage the data? Are you going to migrate from the existing VM to a container? If it's a stateful application, then consider using persistent volumes in Kubernetes and also NFS. If your application going to do a multiple writes, if you have three replicas, then of course you'll have to do certain multiple writes, right? So there are stateful application consideration for this. So once you decide on the runtime that you're going to use, then you have to choose your container orchestrator, which is here we chose Kubernetes. There are other options here like Docker Swarm, Mesos, etc. Right? Now you should also take into consideration for your future growth, like if your company is going for a geo expansion, whether for compliance related you have to run certain application in your on-prem data centers, or if you're okay with running on cloud, then you have like EKS from Amazon, GKE from Google, right? And for on-prem, you have to manage the master by yourself. So that means you have to set up the data store for the Kubernetes master. There are various flavors of Kubernetes you can go about setting up on your own on your on-prem. We chose K3s because it was robust and it was production ready, and it also offers multiple data stores, not only HCD. You can use your RDBMS like MySQL and Postgres as a backend. So you set up your data store for HA, high availability, and then set up your master nodes. Always we recommend more than three masters, so we don't have any split brain issues, right? Once you're done with the masters, set up your container network interfaces, CNI plugins like Cilium, and then you set up your worker nodes and label them accordingly to schedule your workload, which is your applications, and you allow them to join them to the master nodes. Once you have all the basic work the Kubernetes cluster ready, you can go about installing your operational tools like Ingress controller for traffic routing and whatnot. So now that you have the orchestrator ready, you can go about creating your container images. So here you can choose to build your container using a Docker file or build packs, or you can also write the container spec. These are certain various options to build your container, but these requires you to have a Docker engine running and building, whether it's on pipeline or it's on your local environment. There are also other options like Google Gib, which also does containerizing, mainly used for Java applications, where it doesn't require you to have Docker files or Docker engine installed. Right? That reduces the dependency of building a container for you. If you're going to use a Docker file, always make sure you use a multi-stage build. Sorry. So yeah, as I was mentioning, if you're going to use a Docker file, try to use multi-stage build. Look out for vulnerabilities in the base image that you're trying to use. Make sure you use a smaller minimal base image, which means less vulnerability. We prefer distro-less images where there is no root file system. It's just your jar file or your static binary if it's a Go, right? So before using this base image, try to do a vulnerability scan on it. You can use Aquasec TV to scan the images to figure out all the vulnerabilities and go forward for your using it as a base image, right? And once it's done, set up a Docker registry to store these images, enable authentication and container scanning as well on the Docker registry. You can also set up caching so that you don't reach the rate limiting. So anytime the image needs to be pulled, it will be cached from your internal registry rather than reaching the upstream. So now that you've decided on provisioned your cluster, your image is ready. Next step is just the deployment, application deployment. So define the Kubernetes deployment manifest, or if you're going to use Docker Swarm, your Docker Compose files to describe the desired state of your application. There are various tools which you can use to declaratively manage this manifest, customize Helm. You can choose the one that works best for you, where you can do a multi-environment setup using these tools. If you have dev, QA, sandbox, and multiple environments, you can go with this deployment declarative management tools which I mentioned, customize and Helm. Always try to store the secrets in external secrets manager where it's not directly accessible for any one of the dev team or engineering team, so that the secrets are always maintained on an independent server somewhere. And also try to set a reasonable CPU and memory resources. Do not try to over provision your resources so that other pods won't be able to run on the same cluster. Again, this will all come in. You can always fine tune this once you have the monitoring in place, right? So you can either deploy this manifest using the Kubernetes commands for your initial development or POC, or you can set up a CD tool as well to deploy them. Next step is the networking and service discovery. Now that your application is deployed, you have to make sure whether the service going to be accessed internally or externally. So if it's a backend, most probably the service need not be exposed externally. So you can use ingress controllers for traffic routing if your service is exposed externally. And you can also use service meshes for load balancing and doing lots of deployment strategies like Canary or Blue Green, whatnot. And implement service discovery mechanisms for inter-service communication. Kubernetes comes with a built-in service discovery, which is the Kubernetes secret object, where it's an abstraction of all the pod IPs, all the replicas of a deployment, wherein it will only store all the applications which are healthy and able to receive the traffic, right? Once the networking and service discovery is set up, now we can go about monitoring and logging your application. There are a lot of open source tools like Prometheus, Victoria Metrics, Grafana, or even Datadog for collecting and visualizing these metrics. So you can also update the code base, your application code base, to publish custom metrics to gain more insight. For example, I can give you, let's say your application is a SMS service and try to it utilizes multiple providers to send an SMS. In your code, you can actually configure this metric based on the provider, how many success and failure rates that has occurred in a given span, right? Which you can visualize on any Grafana or Datadog. And now that your application is properly deployed, you can now go about seamlessly building your CI/CD tool, right? For example, we are moving away from Jenkins to Bitbucket. pipeline for containerizing our application, so that reduces the dependency of managing Jenkins. And we are also using Argo CD for multi-cluster deployment. Going forward, we'll probably doing on-prem as well as cloud for the multi-container deployment. Yeah, and Argo CD also provides a very good RBAC as well. Take a look at that.
Yeah, thank you, Pawan. So as we
Yeah.
saw that, what are the prerequisite and what are the homework we need to do before even starting to think about containerization, right? So now that we have decided that we will be going ahead with containerization, but does moving the services to containers, will it solve everything? No, right? So you need to do a bit more. You need to think about certain more criterias, like you need, as we spoke in the previous slide, you need to have a platform which will enable you to run the entire container environment, right? So you need to have a platform which will be able to help you to build and maintain the images, right? And it should be able to facilitate pulling those images that were built and published. And then how would you schedule these containers to run and execute? How would the service discovery work between these services? So within the containers, all the services are exposed via internal endpoints. Now how these services will discover each other, how they will talk to each other. So these kind of platform related items which are outside the purview of your application should be also thought about, and then has to be designed that how this entire communication and orchestration is going to happen, right? So that is where you have different strategies. Either you can use Kubernetes, or you can use Docker Swarm, depending on the depending on your requirements and needs. That are you trying to build and scale like several thousand services, or like just one or two few services? So it completely, we will leave it to your goodwill and based on your own requirements, right? So moving on, next is, we would like to show you a very small gist, like how the services look like, and how we will be trying to move into a container environment. So at VIDA, we primarily, all our microservices are built in Java and Spring Boot environment. So we will be talking more into Java related aspects, and how we leverage Kubernetes. So our orchestration at VIDA, we chose Kubernetes as the container orchestration, and primarily runtime is the JVM. So if you can see here, we have like multiple services, and then we use the service registry, and there is a gateway, and all the requests are load balanced between the multiple VMs, and which are running on a physical server, or a rack server, right? So you have, so VIDA deals with a lot of PII data. So we cannot use any public cloud. So most of our services operate out of a private data center, and hence you're seeing as a data center, right? So uh, this is the very simple deployment wherein all our services registry registers to a service registry, and each services talk to the service registry if they want to communicate between each other. Say for example, if service A wants to talk to service B, then it will go to service registry and say, hey, give me the location, basically the IP and the port number of service B, and I would like to talk to the service B. And then service registry will send back the information. Here is the IP and the port number, or the DNS of the service B, and then service A can talk to the service B. So this is the scenario which we were working on, wherein we had VMs. And moving on, so this is how we transitioned into containers. So as you can see, uh, we have moved all our applications into different pods, and then each application is exposed as a service, and then they have an ingress point, and which is again backed by a load balancer, which is facing the public endpoint of our APIs. So Pawan, would you like to add some more here?
Yeah, sure. So here in the earlier diagram, you would have noticed that there will be a latency added whenever you request to try to communicate with service B. So your request will go to first the service discovery, then the service discovery takes a while to figure out the application that is running which you want to talk to, which adds a latency, right? So here you need not set up a service registry like we did in the earlier architecture. Here, like I said, the Kubernetes itself comes with a built-in service discovery, which is our service object here. So which holds all the healthy IPs. Healthy by that I mean the application, if it's responding to all the health checks that you have set up, it considered as the healthy pod. It's able to receive and cope up with the traffic. So the service and object has something called as endpoint slice, which contains all the application IPs which are running, and they can be either communicated internally via in-cluster DNS, or if you want to face them to a public endpoint, you can set up an ingress load balance ingress controller with an ingress object defined with there's a path-based routing, and the request can come to the ingress controller via bare metal load balancer like metal LB or anything. Yeah.
Yeah. So as you can see, just to further add here, previously in our previous screen, we had service A, service B, and then to run the multiple instances of the service, you need to like provision new VMs and then bring up the entire cluster altogether, right? But in the target thing, in the target architecture, you can see that now you can individually scale each services how much ever you want. Say for
Yeah.
example, I'm seeing that we have service A and service B, and then we see that service B needs to handle more traffic than service A, so service B alone can be independently scaled up and scaled down, and you can increase the capacity of service B separately without even worrying about how service A will without even hampering anything on the service A, right? So this is on the communication part, how your services will be transformed from running on a VM to a container environment, right? Now moving on, the next part of the piece is how do you handle the CI/CD process of this, right? So in the current set of things, uh, we were trying to use the Jenkins, and then from the Jenkins we moved to Bitbucket pipelines, right? So in the Jenkins world, a developer would push the code to the repo, and once the code is pushed, then through the Jenkins your application will be packaged, and then it will push to the repository, and then somebody, because it is a Linux based system, we somebody has to log in and then manually pull the packages, and then do the installation of the packages, right? And while we after we move to the container platform, now we switch to Bitbucket pipelines. So the moment developer pushes the code, the pipelines will generate the image, and then the image is pushed to the repository, and now you can just go to the deployment module, which is the Argo, and using the Argo you can perform literally one click deployments. All you have to do is just click on deploy button, and it goes and deploys to the target platform, target environment, which could be a production or your QA or development, and you can further automate all of this to happen just by on the action of your merge of your pull request, right? So this is the CI/CD part which we transformed, and it has like greatly improved the developer experience. So anyone coming into VIDA and between within, like, they can just quickly uh, write a very small feature and then immediately push it to production without zero intervention of anyone, right? So this is how your whole CI/CD also helps us to move faster.
Yeah,
So
the whole intention here, sorry to interrupt you. The whole intention here is to reduce the friction between the developer and the infra-ops. Here, the earlier model, if you see, the developer has to push the code, he builds it, and the infra-ops guys take to cover the deployment of the application because it's a production environment. Here, we are trying to facilitate something called as self-deployment, wherein the developer has the control over certain environments where he can does not depend on the infra-ops people to uh, I know ping them late night, like, hey, I need to deploy this. Can you help me? He can just go by himself and one click, and his application is deployed on Kubernetes. Yeah, this is the intent of this particular CI/CD approach.
yeah. Lastly, we wanted to cover on the JVM because all our applications are primarily Java based. So since we are into container world, your JVM kind of behaves differently within the VM and the container, and it is a very good choice to think about containers which are capable of providing you memory shrinking capabilities, right? So what do we mean by memory shrinking is that traditionally, if you start a JVM based application, you will be defining what is my initial memory, and then what will be the maximum heap that the application is going to use, right? So on the first diagram, if you see that we have the orange space is nothing but the reserved heap. So when we start up the application, we have reserved say 2 gigs of RAM. The application starts with the entire 2 gigs of RAM, and as the application is working and it is being used, so the heap also gets utilized, and then it slowly grows, and then there is a GC event happens, the garbage collection happens, and then your utilization again is resumed, right? But the difference here is that the memory which was reserved is being still held by your JVM process, right? It is not being returned back to the OS. But with the newer and modern garbage collectors like G1, which got introduced which got introduced, and it is enabled by default from JDK 9 onwards, right? So folks, if you're using still on JDK 8, you might want to enable it through the JVM flags, but if you are on JDK 9 and above, then it has been enabled by default, right? So what advantage we get if you look at the second graph, though we started the application with 2 gigs of RAM, you can see that the lot amount of memory is still available to the OS, which is in turn available to the other containers, right? And the memory increase is very gradual and slow, and it is not that at the beginning of the process itself the entire memory is being consumed. So this way the required memory is only being used by the container, and not the entire allocated memory is blocked at the beginning of the application. So this way your applications can be more elastic in nature, and you can have more efficient resource utilization, right? So yeah, with this we would like to conclude here. I hope you got a fair idea about what it takes to migrate your services, what is the groundwork you need to perform, and what all different aspects you need to keep in mind when you're thinking or planning about migrating your applications and start using a container environment. Thank you. Thank you for the time.
Thanks,
Thank you.
everyone.
Okay. Hi, thank you. Thank you, Himalaya and Pavan, for your good
Thank you, guys.
presentation here. And we will get back into you at the Q&A session.
Sure.
And okay, sure. Okay. Okay. And let's move on to our next speaker. Oke, kita bakal masuk ke speaker selanjutnya. Ada dari Mas Zufar. Oke, ya. Halo Mas Zufar.
Halo.
Oke. Mungkin teman-teman segini udah biasa juga melihat Mas Zufar. Mungkin bisa langsung dimulai aja ya.
Oke.
Time is yours, Mas.
Thank you, Mas Baril.
Oke, thank you.
Thank you. Jadi saya terpaksa ngisi ini sebenarnya sih gara-gara nggak ada yang mau nih. Mungkin kalau teman-teman meetup selanjutnya mau ngisi meetup, kabarin saya ke Mas Baril aja ya. Anyway, mungkin so thank you Pavan and for the presentation about the migrating from containerization to migrating from virtualization to containerization. I will try to continue in Indonesia, in bahasa Indonesia. So kalau teman-teman tadi ya, di slide sebelumnya atau di presentasi sebelumnya sudah dibahas tentang bagaimana cara virtual machine itu pindah ke bagaimana migrasi dari virtual machine ke containerization mungkin di Kubernetes. Nah, sekarang misalkan kalau teman-teman sudah punya infrastruktur Kubernetes, lalu bagaimana sih kita melakukan cost saving gitu ya. Jadi yang akan dibahas terutama di sini adalah tentang bagaimana kita melakukan cost saving di dalam network itu sendiri. Yang biasanya mungkin terlupakan oleh banyak engineer sih sebenarnya. Introduce saja saya IM di GoTo Financial, kerjanya sehari-hari dia networking, Kubernetes, dan Istio service mesh. Mungkin segitu aja. Yang pertama kita coba kenalan dulu. Jadi tadi judulnya itu apa ya? Judulnya adalah Optimizing Kubernetes Network Costs with Kubecost and Istio. So mungkin pertama kita coba kenalan dulu apa itu Kubecost. Jadi Kubecost itu adalah tool open source, ini open source tool yang bisa kita gunakan untuk memanage cost dalam Kubernetes, di Kubernetes environment. Kubecost sendiri itu, dengan Kubecost ya, kita bisa melihat utilisasi cost setiap objek di dalam Kubernetes. Contohnya pods, volume, dan juga network. Dan yang nanti bakal kita bahas kenapa kita pakai Kubecost. Dia juga punya integrasi ke cloud provider billing. Jadi misalkan kalau teman-teman punya billing di cloud provider tertentu dan mereka ngasih diskon, misalkan diskon di compute resource-nya, itu bisa otomatis terintegrasi di Kubecost dan bill-nya itu akan otomatis di-sync. Itu bisa. Jadi teman-teman bisa integrasi juga ke cloud provider billing. By default, Kubecost ini open source, bukan by default ya. Jadi Kubecost ini ada 2 versi. Yang versi pertama adalah versi open source, tapi ada versi enterprise-nya juga. Gitu. Jadi mereka provide kayak cloud billing, teman-teman bisa akses dari enterprise support-nya ini. Setahu saya teman-teman dari satu dashboard nanti bisa manage banyak Kubernetes. Nah, kalau yang open source ini satu Kubernetes hanya satu Kubecost saja, seperti itu ya. Arsitekturnya mungkin secara sederhana seperti ini ya. Jadi Kubecost itu sebenarnya membutuhkan data-data dari CI advisor, dan interaksi ke CI advisor ini itu menggunakan implementasi seperti Prometheus ataupun Victoria Matrix yang support query-nya Prometheus. Nah, jadi Kubecost ini sebenarnya dia ngambil data matrix, misalkan kayak memory usage, CPU usage, itu dari Prometheus. Jadi teman-teman kalau mau integrasi Kubecost, pastikan ada Prometheus di dalam cluster tersebut. Dia juga communicate ke Kube API. I'm not really sure about this one actually. Buat apa? Cuma dia butuh di sini. Dan dia juga bisa kontak yang tadi ya. Dia bisa diintegrasikan ke billing data gitu. Billing-billing di misalkan AWS, Google Cloud atau Azure itu bisa di fetch di data-datanya ke Kubecost. Lalu dia juga provide sebuah interface. Ini yang menurut saya cakep banget sih untuk Kubecost ya. Jadi ini adalah contoh dashboard dari Kubecost. Saya coba sensor cost-nya. Ini di salah satu cluster kita. Teman-teman itu bisa melihat overall ini cost Kubernetes-nya seperti apa. Teman-teman bisa melihat tren dari cluster tersebut hari per hari, cost-nya seperti apa. Teman-teman juga bisa breakdown nih cost-nya ini, cost-nya apa aja, di namespace apa aja, itu bisa. Dan yang jadi unik adalah Kubecost ini selain dia bisa melihat visualisasi cost-nya, dia juga bisa goal utama dari Kubecost ini, mereka provide saving capability gitu. Ada banyak sekali feature untuk saving di Kubecost. Saya harap slide-nya kelihatan ya. Yang pertama, ada banyak, teman-teman bisa coba explore sendiri. Feature yang teman-teman bisa dapetin rekomendasi tentang jumlah node di dalam Kubernetes teman-teman. Misalkan sekarang over provision, teman-teman provide provision 10 mungkin dan itu tidak terlalu optimal. Kubecost bisa ngasih data berapa sih jumlah node yang tepat gitu. Teman-teman juga bisa mendapatkan rekomendasi terkait optimisasi request limit di setiap service. Jadi misalkan service A dia request 1 core dan 2 GB, ternyata utilisasinya itu dikit. Nah, Kubecost ini dia bisa memberikan rekomendasi dan juga bisa mengimplementasikannya. Bisa saya bilang otomatis mengganti request limitnya secara langsung itu dari dashboard. Jadi teman-teman mungkin bisa force kalau teman-teman sebagai infrastruktur engineer, dan jika dibolehkan teman-teman bisa langsung force nih, gue nggak peduli servisnya apa, langsung gue force aja dengan rekomendasi di Kubecost. Seperti itu. Ada banyak, misalkan teman-teman juga bisa ngecek apakah ada unclaimed volume, mungkin ada orang yang coba testing ngebuat volume dan tiba-tiba dia lupa di-delete kan, itu kita juga bisa melihat itu. Ini ada salah satu contoh rekomendasi request, teman-teman juga bisa meng-apply-nya atau enable ini, request resizing. Kubecost menamakannya itu request resizing. Jadi teman-teman bisa melihat nih, rekomendasi setiap deployment itu request sama CPU request-nya itu rekomendasinya seperti apa, dan teman-teman bisa melihat current efisiensinya seperti ini. Ya ada yang gede banget, ada yang kecil gitu ya. Ya seperti itulah. Itu sedikit tentang Kubecost. Mungkin kita coba bahas tentang Kubernetes Network Cost gitu. Mungkin saya nggak tahu ya, mungkin ada yang udah tahu atau ada yang belum tahu. Yang belum tahu, khusus yang belum tahu, ini kebanyakan cloud provider itu men-charge data transfer antar availability zone. Ini saya provide 3 cloud provider yang biasa dipakai seperti GCP, AWS, and Azure. Jadi mereka itu men-charge sekitar $0.01 per gigabyte. Okay. Kalau teman-teman pakai DC dan teman-teman ingin mengimplementasikan availability zone, konsep availability zone, mungkin teman-teman pakai data center yang berbeda-beda. Dan lalu bagaimana komunikasinya? Mungkin teman-teman provide dedicated link, misalkan untuk 5 GB per second, dan itu juga teman-teman kena charge kan. Nah, saya kan coba bawa use case di cloud. Jadi kalau kita lihat di cloud, pricing-nya kira-kira seperti ini. Meskipun itu kecil ya, $0.01 per gigabyte, kalau teman-teman tidak monitor itu bisa signifikan impact-nya. Gitu. Jadi di sini kita lihat bahwa cloud provider itu men-charge data transfer antar availability zone. Misalkan teman-teman punya pod komunikasi ke pod lain, atau service A komunikasi ke service B, dan service B ini ada di zone yang berbeda, itu di-charge. Gitu. Terus teman-teman dari pod ini komunikasi ke database, dan database itu ada di availability zone yang berbeda, itu di-charge. Atau kena keluar, itu juga di-charge gitu loh. Jadi kita harus properly monitor kalau apalagi di large scale Kubernetes ya, misalkan teman-teman punya 100 node Kubernetes, 3000 deployments or something like that, yang bisa jadi traffic networknya itu tinggi gitu. Jadi teman-teman kita perlu aware di sini juga selain request limitnya. Gitu. Sebenarnya ada beberapa challenge kenapa kita sebenarnya tidak fokus ke network cost. Yang pertama adalah kita tidak aware tentang network cost itu sendiri. Kita nggak tahu ada bahwa itu di-charge, atau memang jika kita lihat dari dokumentasinya itu hanya dikit, $0.01 per gigabyte, ya paling berapa sih? Nah itu sebenarnya. Kita tidak aware di situ, dan visibility-nya juga limited gitu. Jadi by default itu Kubernetes tidak memprovide matrix ini. Matrix antar availability zone. Trafficnya kita bisa dapat request masuk, data masuk dan data keluar di dalam sebuah kontainer, tapi kita tidak tahu nih ini apakah ke zone yang berbeda atau ke zone yang sama gitu. Oke. So untuk mengatasi challenge ini kita bisa menggunakan Kubecost. Jadi Kubecost itu dia provide sebuah tools atau optional utility, bisa kita bilang, untuk mendeteksi network cost gitu. Nah, teman-teman bisa langsung coba aja install Kubecost, dan teman-teman bisa langsung buka nih ini installing network cost configuration, gampang banget. tinggal enable aja network cost enable true, something like that. Nah, network cost utility ini dia menggunakan daemon set yang diinstal di setiap Kubernetes node. Nah, si daemon set ini dia bakal nge-intercept bukan IP table sih. Dia bakal nge-intercept sesuatu, saya agak lupa namanya. Dan dia bisa nge-determine nih apakah destination dari node ini itu ke zone yang berbeda atau ke zone yang sama atau ke region yang berbeda atau ke internet. Dia bisa tahu itu. Agak unik emang. Nah, Kubecost ini juga dia provide sebuah API. Jadi misalkan kalau teman-teman deploy Kubernetes teman-teman di banyak cloud provider. Dan pastinya teman-teman mungkin kalau teman-teman build cost dashboard teman-teman sendiri, jadi itu diabstraksi ya dashboard cost itu dari cloud, teman-teman bisa nih integrasi Kubecost API ini untuk supaya kita bisa charge back product engineering seperti itu loh. Jadi hey tim produk cost-nya seperti ini, gua charge back ke tim produk gitu daripada tim infra yang nanggung cost-nya. Itu bisa kita lakukan. Di network utility tadi ada beberapa traffic classification, bisa kita bilang. Jadi nanti saat teman-teman nge-deploy daemon set ini, dia akan otomatis nge-expose matrix. Jadi nanti kita bakal dapat matrixnya nih. Kita bisa dari dokumentasinya sih akan ada 4. Apakah destinasi atau destinasinya itu in zone gitu. Jadi di dalam satu zone, misalkan service A communicate ke service B di availability zone yang sama. Nah, kalau di availability zone yang berbeda atau di dalam satu region yang sama, tapi dia berbeda zone atau dia juga bisa mendeteksi nih apakah dia cross zone atau cross region. Kalau teman-teman mungkin mengimplementasikan Kubernetes cross region, itu juga bisa dilihat datanya. Atau kita bisa tahu nih apakah data ini ke internet via NAT atau enggak, seperti itu. Nah, ini salah satu contohnya di salah satu cluster kita. Dalam 5 menit itu kita mendapatkan data transfer sekitar 177 GB. Nah, kalau di AWS nih itu at least $500 per hari. Itu sih sebenarnya. Ini salah satu contohnya di salah satu cluster kita, itu 177 GB cross all availability zone call-nya. Jadi ini sangat berguna banget kalau teman-teman ingin mengimplementasikan untuk cluster yang trafficnya gede gitu. Teman-teman juga bisa nih ngebuat sebuah dashboard di mana dengan matrix yang tadi ya, Kubecost itu tadi network utility ini dia provide sebuah matrix di mana teman-teman bisa sampai ngedetect sampai deployment name-nya. Jadi deployment ini dia ingress-nya masuknya berapa, egress-nya masuknya berapa, kita juga bisa ngeliat nih apakah yang masuk dari ingress ini dari cross zone berapa, dari same zone berapa, egress-nya juga sama. Dia manggil service lain, service line ini ada di zone yang berbeda atau di zone yang sama, kita bisa tahu nih sampai level data transfernya per 5 menit. Ini kalau kita configure per 5 menit. Nah, itu salah satu jadi kita bisa tahu ya dengan Kubecost, apalagi dengan network cost tadi, kita bisa tahu nih visibility-nya sampai ke beda zone, cross zone atau same zone atau ke NAT gitu. Jadi kita bisa tahu cost-nya itu berapa gitu. Nah, tadi kita udah provide visibility-nya. Sekarang lalu bagaimana sih kita udah tahu visibility-nya nih. Kita udah cross charge developer atau product engineer. Ini loh cost kalian, tolong manage gitu ya. Lalu bagaimana cara mereduce cross zone data ini? Yang pertama itu kita sebenarnya bisa, yang paling gampang sih ya, nggak usah pakai, kita hanya pakai satu zone, gampangnya seperti itu. Dan di sini kita bisa lihat dengan menggunakan satu zone, data transfer ini hanya ya 0 dong, karena kan tidak dari data yang kita dapatkan itu komunikasi antar sama di single zone itu gratis gitu. Nah, yang ini sangat gampang diimplementasikan. Yang jadi masalah adalah ini tidak suitable untuk production. Bisa bagaimana kalau terjadi misalkan data center kebakaran gitu, zone-nya mati gitu. Nah, kalau kita hanya pakai satu availability zone, ya tewas dong, service kita gitu. Itu tidak suitable untuk production. Yang itu mungkin suitable untuk non-production. Cuma kalau menurut saya, itu tidak suitable untuk regulated industry. For example, ada audit untuk disaster recovery. Nah, kita bisa menggunakan konsep availability zone untuk disaster recovery dong. Tapi kalau biasanya itu akan ada audit. Nah, kalau non-production setup kita tidak ada availability zone-nya, bagaimana kita melakukan audit tersebut? Bagaimana kita melakukan simulasi bahwa DR ini berhasil? Tidak mungkin dong kita melakukan audit simulasi disaster recovery di production, itu sangat tidak mungkin. Jadi itu menurut saya tidak suitable untuk regulated industry. Jadi it depends. Cuma ini adalah solusi yang sangat mudah diimplementasikan gitu untuk mereduce network cost. Yang kedua adalah kita bisa menggunakan locality load balancer. Jadi sebenarnya locality load balancer ini tujuannya adalah semua request dari service manapun itu di forward ke service, misalkan nih service 1 mau manggil service 2. Request-nya itu daripada di load balance ke zone yang berbeda, dia akan lebih prefer di forward ke service di zone yang sama. Iya seperti itu sih paling. Ada beberapa pros and cons untuk ini, untuk locality load balancer. Yang pertama adalah prosnya itu mungkin improve latency ya, karena kan antar service itu sekarang komunikasinya hanya di zone yang sama gitu. Jadi mungkin improve latensinya sedikit. Kita juga berdasarkan data yang kita coba itu bisa mereduce up to 90% cross zone data transfer charges, hampir 90%. Dan ini juga mereduce impact misalkan kalau ada isu dengan zone yang lain gitu. Misalkan ada zone A, B, C. Kalau misalkan service A itu manggil service B di 3 zone yang berbeda ini, bisa aja misalkan kalau zone B mati, misalkan kalau kita pakai gRPC, ada something like that, itu mungkin bisa menimbulkan isu. Cons-nya itu ini bisa dibilang trafficnya itu bakal hanya akan di forward ke zone yang sama gitu loh. Trafficnya hanya akan di forward di zone yang sama. Itu mungkin bisa menimbulkan kok load balance-nya nggak benar gitu. Kenapa pod misalkan service 2 di zone A itu lebih banyak dapat traffic daripada di zone yang B gitu. Jadi itu menurut saya trade off-nya sih. Ada 2 solusi untuk mengimplementasikan locality load balancer. Yang pertama adalah kita bisa menggunakan Istio locality load balancer, dan yang kedua adalah Kubernetes topology aware hints. Mungkin saya akan coba fokus ke Istio locality load balancer karena kita memang belum coba spike atau implement. Kita udah spike sih Kubernetes topology aware routing, cuma kalau dilihat dari dokumentasinya itu mereka tidak bisa jamin 100% bakal di forward ke zone yang sama gitu. Dan Istio kita bisa at least mereka bisa provide itu. Oke, kita akan coba fokus ke Istio locality load balancer untuk saving cost. Jadi untuk mengimplementasikan Istio locality load balancer itu kita membutuhkan yang namanya outlier detection. Ini syarat untuk mengimplementasikan locality load balancer. Apa itu outlier detection? Itu mirip seperti passive health check. Jadi itu mirip seperti passive health check. Dan Istio locality load balancer ini dia provide beberapa policy. Jadi tadi kita tidak bisa secara fleksibel dengan topology aware hints, cuma dengan Istio locality load balancer kita bisa memilih 3, yaitu default, distribute, dan failover. Nah, saya akan coba bahas untuk distribute dan failover-nya. Kalau ini mungkin dari contohnya ya. Jadi kalau ada service yang mau komunikasi ke service foo.default, kita bisa mengimplementasikan, ini default-nya ya. Jadi kita cukup mengenable locality load balancer, set to true, ini Istio configuration, lalu kita juga mengenable outlier detection. Kita juga bisa mengenable distribute policy. Jadi teman-teman bisa ngatur nih, Oke, kalau ada yang manggil foo.default.service cluster local, saya mau kalau dari zone A itu 90% ke zone A dan 5%-5%-nya ke zone B. Begitu juga untuk zone B dan zone C dan zone C gitu. Itu bisa dilakukan. Teman-teman bisa berkreasi di sini. Yang ketiga, teman-teman juga bisa melakukan ini nih. By default, semua yang dari zone apa nih? Ini mungkin yang dari zone A bakal di forward ke zone A. Wait, ini agak aneh sih. Saya agak bentar. From to. Oke, mungkin saya belum pernah tes ya. Mungkin ini bisa kita bilang, mungkin nanti teman-teman bisa explore sendiri. Kita nggak explore ke failover sih sebenarnya. Cuma teman-teman bisa lakukan failover seperti ini. Jadi kalau misalkan dari zone A, kalau zone A-nya mati akan otomatis di failover ke zone B, mungkin seperti itu. Nah, dari dengan Istio locality load balancer ini, kita bisa ngelihat nih, ini adalah salah satu testing. Kita coba load test menggunakan K6-nya Grafana. Teman-teman bisa lihat address-nya itu sekitar 800 MB per second untuk cross zone traffic-nya, dan same zone-nya itu hanya sekitar 400 MB. Saat kita start enable locality load balancer, teman-teman bisa lihat bahwa cross zone-nya itu berkurang secara drastis dari 750 MB atau 800 sekitar segitu, itu berkurang secara drastis hingga hampir mungkin 50 MB per second aja gitu. Dan teman-teman juga bisa lihat traffic di same zone-nya itu naik. Jadi ini bekerja dan bisa kita bilang kita sudah bisa melakukan cost saving untuk network cost. Lalu solusi yang ketiga ini juga masih kita masih masak ini sih sebenarnya, masih kita coba, yaitu teman-teman juga bisa mengimplementasikan HTTP compression. Teman-teman kalau teman-teman service-nya itu menggunakan HTTP, teman-teman bisa mengimplementasikan HTTP compression berdasarkan data-data yang kita ambil, berdasarkan data dari internet ya, itu bisa reduce up to 70% bandwidth. Jadi kita bisa reduce up to 70% dari cross zone datanya itu sendiri. Paling dari saya itu aja sih. Mas Baril.
Oke, thank you Mas Zufar atas presentasinya. Menarik banget ya buat cost saving, cost dan juga beberapa tips trik untuk kita bisa cost saving di Kubernetes ini. Oke, I think we can go to the next agenda. So for the next agenda, I think the Himalaya. Okay, I will try to add you. Okay, and Pavan. Okay, so for the next agenda, we will enter the Q&A session. Okay, and I think you already answered some of the question.
Yeah, we answered most of the questions.
Okay.
So
okay. I think
if we have any new questions we can take.
Okay, sure. Or do you have any additional explanation for any question? We can try to run by one. I think we can. The first question, I think from the Irviva. Okay, do you have also backup your cluster set? Do you have any additional explanation for this question?
Yes, we do backup our cluster state. At the moment, as I mentioned, we are using a K3s cluster for our on-prem, and we are using a data store Postgres HA deployment. We are backing up the entire Postgres as well as the Kubernetes cluster state.
I see.
Yeah, you can use Velero for open source, backing up your entire cluster as well. You can take a look at that.
Mm-hmm. And for the ATCD things, do you have any backup or yeah? So this is all for only the cluster or?
Yeah, this is only for the cluster.
I see. Okay, sure. Okay, I think for the next is from the
backing up just to add that. So backing up the cluster stage is very important because at any point in time you can, if something goes wrong, that state would be very important to recover from the from any disaster. right? So
No.
your cluster is gone. So that is why backing up also is very important.
Sure. Agree on that. Okay. For the next question, I think this from the Zufar. Yeah, if we have to, how do you migrate one service to the
Yeah.
Kubernetes while
So
keeping the other VPN?
we have already answered this in the chat, but anyway, I will repeat it here. So if we have two services to communicate each other, one VM. So this is the exact scenario that we did at VIDA also. Personally, we went through the same thing because we have like almost 20 plus services currently in production, and we did stage by stage migration. So our parallel container environment was up and running, and existing VM environment was up and running. So uh, usually the service to service internal communication is via the internal HTTP APIs, REST APIs, right? So the services which are running in VM, they still continue to run. And when they want to talk to service B, which is being migrated to the container, it would expose, and it would via the ingress, we will expose it to the internal network, that this service will be accessible via a different HTTP endpoint. So what would happen is we made the code changes. Instead of talking to the inbuilt service registry, now you can directly talk to the endpoint exposed by the ingress of the Kubernetes environment. So that way, both these services can talk to each other.
I see. Do you have any additional questions, you? Any response?
No.
Okay, all good. Okay, sure. Okay, I think for the next is from the Muhammad Al Safi. Oh, sorry. I think this is not the right question. Okay, from this J, yeah. The best security, any additional question from your side?
Yeah, so again, the security practices in general, the OWASP provides you a lot of general practices, but it depends from domain to domain, what type of environment, what type of domain we are operating in. Say if you are in banking, then it is more tighter and stricter. But if, say, for example, you're running just a shopping cart, then your security practices again differ slightly, right? So the general practices are like running your static code analysis, running your scanner if you are using multiple libraries and packages. And then finally, when we are building the container, we can also run container level scans, which will try to find out are there any open vulnerabilities, right? So just with the security point of view, right? One more difference between running on VM and container is that when you're running on the VM, you need to like do huge planning, saying that, okay, what is the OS image we need to change? If there is a security patch which is released, say for example, for OpenSSL, there is a security patch released, you need to like first literally bring down the application, then you have to upgrade your OS version, then you have to apply the patch for OpenSSL library. So it's a very tedious process, right? But for container, since it is already running with a very minimal version of OS and everything, all you have to do is just change the container image version and restart your and then and redeploy your containers. So Kubernetes will seamlessly migrate all your traffic to the new containers, and hereby updating all your security vulnerabilities also, right? So it also becomes very seamless.
Correct. Okay, let me try to find another question. I think okay. So from the yoga, is migrating a VM database server to container best option?
This depends on two factors: whether your database is a huge, if it's handling like millions of records. We usually try to avoid migrating the databases onto Kubernetes because one of them is the stateful set management. It'll cause issues if you're setting up a master slave deployment and the deployment rolling out of the new Kubernetes version. There will be a bit hiccups there. You'll have to take care, intensive care to be put in there to migrate the stateful set onto new nodes when you're upgrading the underlying worker nodes. And also, uh, yeah, it's just we don't recommend to use
Yeah.
a Kubernetes stateful set for database server. If it's a
Correct.
lightweight like Redis, you can go ahead. There is no issues. Like if it's a
Mhm.
master slave deployment of a MySQL or Postgres, we try to recommend use a VM as well, VM itself, yeah, or
Yeah.
any
Yeah.
managed
Agree.
database servers.
Agree on
So
that.
just to add that, right, it again it depends on what is the choice of your database. If you are running a relational database like MySQL, Postgres, they are
Mhm.
designed to run on a bare metal like much
Yep.
more efficiently than on a VM or than on a
Mhm.
container, right? But if you
Mhm.
look at the upcoming new databases which are more distributed in nature, for example,
Mhm.
like Cockroach DB, right? For these kind
Yeah.
of databases, maybe you can think about having running it in containers, right? But again, it
Yep.
all depends on if we are primarily using RDBMS, then as Pawan mentioned, it is better not to touch it.
Yeah. Correct. Correct. Yeah. Because if we, yeah, just like using the Postgres or yeah, the DBMS, it's very tedious process to debugging
Right.
things or yeah.
And the biggest headache is about recovery from
Ah,
failure,
correct.
right?
Correct. Correct.
Especially the replication failures, right? If there is a quorum which is broken, then it is literally hard to recover from failures, right?
Yep. 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 Agree. 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 Okay.
You can go with the
So.
dev environments.
Mhm.
You're good to try with the dev environments like KubeDB is there. You can give it a try, but
Mhm.
not for production though.
Yeah.
Yeah. Yeah. Yeah. Correct. Agree on that. Okay. Sure. Okay. For the next question, thing yeah. How do you manage the artifact Java in CI/CD? Do you have any like artifactory things or something like
Yeah.
that?
So again, this thing depends on how we are how you are planning your platform, right? So we chose the way not to maintain the artifacts, basically the
Mhm.
jar files, rather than we chose to maintain the images, because image is self-independent, which can be started anywhere you want, right? But if
Mhm.
you package jars, then how would you package your configurations? How would you package your environment variables, etc., right? So with the application image, you can package certain default configurations, you can package certain default files that you want, etc., etc., right? Basically all the required items that you want along with your application, so it becomes as a single image, and you can just spin it up anywhere you would like to. So we don't really maintain artifacts, we maintain images within an image repository. So
I see.
certain libraries that we have, that we use it for internal development, and
Mhm.
also shared libraries. So for those
Mhm.
libraries, we use something called Nexus,
I
which is
see.
very similar to JFrog's Artifactory.
I
So,
see.
and also previously, before on the VM, we were running on CentOS, a Red Hat based Linux distribution. So the
Mhm.
packages were based out of RPM packages. So
I
Red Hat
see.
Package Manager, right? So you would do yum
Mhm.
install, or which
Yep.
is equivalent of Ubuntu apt
Yeah.
get,
The package. Yeah.
yeah,
Mhm.
apt get, right? So
Mhm.
even for those packages also, we were using Nexus. Nexus
I
provides
see.
you a yum repository manager. So we were publishing the internal jars, the library jars, to the Nexus Maven repository, and we were publishing our packages to the Nexus yum repository.
I see. I see. I see. So, you only like serving or yeah, catching the um like primarily library that you use on the your app, now, right?
Yes, right,
Okay, sure. Mhm. Because it will take more build time, yeah, if you don't have any catching or something like that.
right, right.
I see. Yeah, yeah, correct. Okay, sure. For the next, I think, yeah. Do you have any like experience
Okay,
about the
so
IIS?
we work primarily on Java based things, but I can
I see.
relate to what Masaraf Key wants to ask. So IA is
Mhm.
nothing but the Microsoft version of a web server.
Mhm.
So
Mhm.
so we did a recent migration of our authentication server, which wherein we have an application as a WAR file, WAR file, and then we have a application server which is the Wildfly application server, right? So to put in the similar context, you can say that the the Wildfly server or the IaaS server runs as a separate instance, and then all these application servers provide you a directory or a mount point where you can drop your applications, where you can drop your web application, and the event listener within the web app server will pick it up and then deploy it, right? So this is one way of doing things. The second way is you would package all your application within the within your deployment directory of your web application server, build it as a single image, and then bring it up, right? Say for example, you're using Tomcat, and within Tomcat you're going to deploy a .war file in the deployments directory. What you do is you would take a base image of Tomcat, and then you would move your application var into the Tomcat's deployment directory, and then create a final custom new image, which is a combination of your Tomcat image and your war file, and then you spin up a single instance of the container,
Yep.
which would spin up your Tomcat and also will be deploying your application. So in the similar context, you can package your application into IaaS and then bring it up.
I see. Yeah.
So that would be
Okay.
one of the very straightforward, simple approaches. But like it depends how complex is your application, how heavy is your application, right? So those factors we need to rethink about it.
Yeah.
We
Yeah.
might want to adopt different strategy based on the requirements.
Yeah, because if the image are getting bigger, and it will like get a lot of the
Correct.
building time and something like that.
Correct.
Okay, I think next is to Mas Zufar. I think you have like question. Do you prefer Indo or English, Mas? From the yoga.
Both. Okay. Thank you, Mas Yoga. Kubecost ini saya lihat bisa untuk on-prem, itu base hitungannya apa ya? Jadi untuk Kubecost kan tadi bisa kita lihat ada integrasi ke cloud provider ya. Untuk on-prem itu base hitungannya adalah kita bisa masukkan sendiri data-data model pricing kita. Misalkan untuk satu CPU itu cost per bulan itu berapa dolar atau berapa ribu rupiah, itu bisa kita bisa masukkan. Jadi saat Mas yang install Kubecost di Kubernetes cluster, Masnya bisa ngecek CPU-nya berapa, RAM-nya berapa, GPU berapa, storage mungkin per gigabyte per bulan. Ini harus dicek lagi sih di instalasi manifestnya. Cuma sebenarnya kita bisa nge-override atau kita bisa meng-custom pricing kita per core-nya. Jadi Masnya bisa define sendiri di data center yang sekarang sebenarnya sih saya bayar berapa untuk misalkan CPU per bulan gitu. Jadi Masnya bisa selain misalkan biaya di awal, Masnya mungkin bisa calculate itu tergantung kalkulasinya seperti apa nanti, dan Masnya bisa langsung masukin itu langsung bisa masukkan di mana? Di Kubecost saat instalasi. Itu bisa. Jadi base cost-nya itu atau base pricing-nya bisa kita configure untuk on-prem. Begitu. Paling itu aja.
Oke, thank you, Mas Zufar atas jawabannya. Oke, ini ada pertanyaan lagi dari J.
Kira-kira data di Kubecost itu berapa lama ya? Apakah bisa lihat cost selama sebulan? Jadi kalau Masnya pakai yang free, itu setahu saya metric retention-nya itu hanya 15 hari. Metriknya ya, data-data misalkan, jadi kita hanya bisa melihat data utilisasi atau itu hanya 15 hari. Cuma itu metriknya gitu ya. Tapi hasil Masnya bisa pakai untuk optimisasi. Jadi misalkan kan Kubecost itu punya mekanisme untuk melakukan optimisasi sebuah deployment. Request-nya ini sebenarnya propernya berapa gitu ya. Itu kita bisa melihat bisa sampai 1 bulan setahu saya sih. Jadi kita udah pernah pakai. Jadi kita melihat nih data utilisasi selama sebulan itu disupport sama Kubecost yang free. Jadi hanya metriknya aja yang 15 hari. Cara ngakalinya itu gampang. Kubecost itu punya API. Jadi masnya tinggal panggil aja,
Scrap ya.
taruh di spreadsheet atau ya seperti itulah. Jadi
Ya,
data-data itu akan tetap ada gitu kan. Itu cara ngakalinya sih. Paling itu.
Oke,
Jadi
mantap.
untuk lihat cost selama sebulan bisa. Data 15 hari itu Mas query terus setiap hari masukin spreadsheet. Itu bisa sih. Kalau enggak ya pakai yang paling itu dari
I see. Oke, thank you. Mas Zufar atas ngakalinnya juga ya. Oke, kita ada mungkin sekitar 5 menit lagi. We have like 5 minutes again for this Q&A session. Okay, I think for the Mas Yoga already. Okay, from the Mas Ehsan. If the VM is vulnerably, is it the container too? If yes, how we protect it? Okay, mungkin any open to answer?
Container 2, yes, it is. So container also is an executable, right? So any kind of attacks are not protected in container. So the one good thing that you can do is you can immediately spin up new containers, right, without even affecting your service. So that the previous the best thing about containers is that they are immutable images. So when an instance is running and you made any changes, if you restart it, it rolls back to the previous state, the state in which we packaged the application, right? So that is the greatest advantage we get with running containers. So if you detect that there is an attack, then the least you can do is quickly restart it so that your application is now back to the previous healthy state.
Yeah, and also migrate the VM to a new host. Try to secure it and move your workload to that as well.
Okay, sure. Okay, and I think for the next, for the last question from the Aditya Kusnandi, for the alerting, that I think VIDA, yeah, there misspell of
It's okay.
misstep. Okay.
No problem. Yeah. So again, so VIDA, we use Datadog for our monitoring and alerting. There are other open source options also available. So for logging also we use so for all the 3 items that we mentioned, we are using Datadog. And you can use other tools also to perform the similar things: monitoring, alerting, and logging. So you can use like Kibana, Grafana, right? So that those tools are also available, which are free of cost and like open source. Datadog is a paid thing, so you might want to think about it. Talk to your organization before adopting. What will be the cost projections? So it's similar to using AWS, right? If you start using AWS, then what will be your cost projection? Similarly, you have to perform a cost planning if you are planning to use Datadog.
But we recommend try to use as many open source tools as possible, because nowadays most of the open source tools provide the capabilities of these these commercial products, right? Grafana and Prometheus is self-sufficient. If you're just starting to move to a container environment, and for tracing you can use Jaeger or whatnot. Yeah. Don't go full blown all of a sudden. Just try to look out to your research on the open source tools, and then gradually move to a commercial product, even if it is necessary, if there's no other options left for you.
Yeah. since like the APM things or is only available for the enterprise product. But if you use like Prometheus Grafana, you need like spare some manpower to manage that Prometheus cluster or Grafana.
Right.
Yeah, that's why we say that when you're starting, start with some basic open source, and then as your application scale and you get the budget approvals to use the managed services, then you can slowly migrate, and you won't see much difference in migrating. It is very very simple to migrate.
Correct. Agree on that. Okay, sure. I think we already answered all the question, and I think thank you very much for Mas Zufar and Pavan Himalaya for the great presentation about how to we can migrate from the VM to container and how we like try to optimize the cost of the Kubernetes. And thank you very much. And I think we can go to the next session. Okay. Thank you, Himalaya and Pavan. Thank you.
Thank you, everyone. Yeah.
And so far. Okay. We can go to the next session. Is this what? Okay. Okay, Q&A, we already doing that. And for the announcement, I think we have additional announcement from the VIDA. Okay, and we'll try to share. Hi, Kristen. Okay.
Hai. Halo semuanya, selamat malam.
Oke.
Thank you Mas Bahril dan Mas Zufar yang udah setup acara ini ya, kolaborasi dengan VIDA. Nah mungkin saya sebentar aja sih, paling 5 menit mau umumin program terbarunya VIDA. Saya bisa share screen Mas Bahril sedikit aja.
Oh yes. Oke. Bisa di share screen dulu aja Kak.
Oke.
Nanti saya coba bring up ke main stage. Oke, sure. Oke.
Aman ya?
Oke, aman. Oke. Time is yours.
Oke. Nah, kita kebetulan dari VIDA ada program terbaru dan waktunya juga limited. Kalau misalnya teman-teman tahu, kita kan dari VIDA ini salah satu platform untuk identity verification yang berbasis sertifikat ya. Nah, atau disebut dengan PSRE. Nah, untuk produknya sendiri kita ada identity verification sama digital signature. Nah, ini kita ada program di mana teman-teman bisa coba produknya VIDA untuk baik dari VIDA Verify dan juga VIDA Verify dan digital signature-nya. Nah, di program ini kita ada grup, event, salah satunya juga contoh dengan kolaborasi dengan Cloud Native dan Kubernetes ini juga ada kredit itu di mana bisa mencoba gratis. Teman-teman misalnya dari company-nya kebetulan emang membutuhkan solusi ini, bisa menggunakan ini gitu. Jadi kita ada kasih limit untuk mencobanya. Saat ini sih ada 3 bulan untuk coba dan gratis. Seperti itu. Selain itu kita juga ada grup seperti itu. Nah, ini untuk mungkin gambaran besarnya, secara verify kita ada 300 verification, terus habis itu untuk VIDA sign, kita ada 300 envelopes dengan 3 bulan limit. Jadi itu gratis untuk company-nya teman-teman. Jadi ini ada term and condition, nanti saya bisa share juga detailnya kalau misalnya emang tertarik. Jadi teman-teman bisa langsung scan aja yang mungkin kebetulan lagi butuh atau foto untuk submit, apply untuk program ini gitu. Selanjutnya juga kita mungkin teman-teman ada yang pengen join di grup kita. Kebetulan grup developer kita juga baru kita set up untuk edukasi tentang identity verification dan digital signature, atau secara umum teman-teman bisa scan langsung dan join di grup itu. Udah sih dari saya ya Mas Bahril.
Oke.
Sekian dulu.
Oke.
Mungkin sampai ketemu lagi ya di acara-acara Kubernetes kolaborasi dengan VIDA. Thank
Oke, thank
you.
you Kak Christine. Oke, thank you. Oke, buat next session bisa ya, tolong teman-teman bisa tolong isi feedback formnya. Buat feedback buat acara kita hari ini dan acara kita buat kedepannya, mungkin teman-teman mau ngisi request materi apa, ataupun bagi teman-teman yang pengen menjadi speaker buat meetup kita di selanjutnya bisa patch saya atau kontak aja saya atau Zufar atau teman-teman organizer yang lainnya, bisa langsung coba dikontak aja. Terus mungkin buat beberapa penanya yang beruntung, tadi ada Kak Irviva, terus ada Mas Yoga Satria, terus ada Mas Yoga Hanggara, sama ada Mas Jay Tomlinson. Bisa coba PC saya di Telegram. Oke, mungkin teman-teman bisa tolong isi dulu buat feedback formnya. Oh ya, dan untuk materi-materi dan slide, nanti bakal ada di GitHub kita, nanti bakal kita update di sana. Jadi teman-teman bisa coba melihat atau ya bisa ngelihat atau bisa ambil di GitHub kita. Nanti bakal kita update di GitHub kita. Oke. Mungkin sekian dari kita. Terima kasih buat teman-teman yang udah memang hadir pada meetup kita pada malam hari ini. Sampai berjumpa di meetup ke depannya. Thank you. Bye-bye.